Hello, welcome back to the channel. So let's do a mixed problem on calculating definite integral using partial fractions and also calculating the derivative of a definite integral, which is in terms of a variable. Like in this case, you have your definite integral with endpoints that are functions in this case. Functions in terms of x, right? So now, first of all, we have to give a formula for f of x, capital F of x, that does not involve an integral, which basically means we will have to solve this indefinite integral over here, right? So now we know that we can easily write 1 upon t square minus 9 as simply 1 upon t square minus 3 square, which is simply 1 over t minus 3 t plus 3, right? And now you can use partial fractions. 1 over t minus 3 t plus 3 can be written as a over t minus 3 plus b over t plus 3, and now you can equate the numerators on the left hand side with the right hand side. It would simply be 1 equals a times t plus 3 plus b times t minus 3. Again, we are using the same concepts that we discussed in the previous videos about partial fractions. So if you still didn't get this concept, the whole concept over here, I would highly suggest you to first watch my previous videos on partial fractions in order to get a good idea about what we are doing in this question over here. So now you have this expression over here. We will compare. So first let's combine the relevant terms together. So for the coefficient of t, we have a plus b. For the constant term, we have 3a minus 3b over here, right? And since on the left hand side we don't have a coefficient of t, so a plus b is equal to 0. 3a minus 3b is equal to 1. From this expression, a is equal to minus b. If a is equal to minus b, we can write this as simply minus 3b equals 1, minus 6b equals 1, b is equal to minus 1 by 6, and if b is equal to minus 1 by 6, according to this expression, our a is equal to 1 by 6 over here, right? So we can write this expression as simply a is 1 by 6, b is minus 1 by 6. So a is 1 by 6, b is minus 1 by 6. And now, since we are calculating the definite integral, which is from t equals 1 to t equals x, so this is t equals 1 to t equals x, which would be simply integral of this expression dt minus integral of this expression dt with the same bounds over here, right? So now we know that this would be simply 1 by 6 ln t minus 3 with the bounds as 1 and x. This would be minus 1 by 6 ln t plus 3 again with the bounds 1 and x over here. And now if you calculate that, you'll simply get 1 over 6 times ln x minus 3 minus ln minus 2 minus 1 by 6 ln x plus 1 minus ln 4 in this case, right? So now we know that since this is the absolute value of minus 2, our expression would be simply 1 by 6 ln x minus 3 minus ln 2 minus ln x plus 1 plus ln 4. So I basically combined this 1 by 6 with this 1 by 6 and then wrote the second expression by taking everything together, right? So now this would be your final answer to the definite integral of this expression over here. You can also simplify this answer, but if you leave your answer as it is as well, it will be your correct answer as well. So again, we use the same concepts of partial fractions that we discussed in the previous video to solve this integral over here, and this was a fairly simple problem, right? But now in the second part, we have to calculate the derivative of this definite integral over here. Let's write the original integral first. So the original integral is basically calculating 1 upon t square minus 9 dt from t equals 1 to t equals x, right? And now we have to calculate the derivative of this integral over here. And we will use the same concept that we discussed in one of our previous videos when we used to calculate the derivative of definite integrals. So if you have not watched that video where we discussed in detail about calculating the derivative of a definite integral, I would highly suggest you to first watch that video in order to get the full context of this video. So in order to calculate the derivative, what we do is we first plug in the upper endpoint into this function over here, and then take the derivative of the upper endpoint. So let's first plug in the upper endpoint into this function. So it would be basically 1 upon x square minus 9, and then we take the derivative of the upper endpoint. The derivative of the upper endpoint, since the upper endpoint is x, so derivative of x is 1, right? So we'll multiply it by 1, and then we'll do the same thing for the second expression. We will plug the lower endpoint into this function. So if you plug in the lower endpoint in this function, it would simply be 1 upon 1 square minus 9, and then you'll take the derivative of your lower endpoint. Since the lower endpoint is a constant, the derivative of a constant is 0, and once you have both of these expressions, you will subtract these two expressions over here. And now, since this term is equal to 0, so the derivative of this definite integral over here would simply be calculating 1 upon x square minus 9 in this case. So again, we use the same concept that we discussed in the previous videos, where we talked about a very interesting formula that you can use in order to calculate the derivative of a definite integral in these type of questions. So that's it for this video. Again, feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.